Here in this video, let us solve some problems based on circles. The question goes like this. The radius of a circle is 13 centimeters and the length of one of its chords is 10 centimeters. Find the distance of the chord from the center. Okay, now let us draw the diagram based on the question. We have a circle of radius 13 centimeters. So let us draw a center point of the circle, the vertex. So now let us draw the radius as 13 centimeters. Now it also says that the radius of a circle is 13 centimeters. We've done that. And the length of one of its chords is 10 centimeters. Now we can draw this chord wherever we want in the circle. Say for example, we can draw it here and say it is 10 centimeters. But now what is the relation between the radius of a circle and the chord? I mean, why is the question in such a way that we need to do something with these two? You can't draw the radius here and you can't draw the chord and make some sense out of it. So what we have to do is, we need to draw the chord such that it touches the radius. We can even draw the chord and then maybe join the radius like this. This is going to be 13 centimeters. This is also fine. But the first way that I was supposed to do was like draw the radius of 13 centimeters first and then draw the chord like this, which is again 10 centimeters. Both the methods are absolutely right. So now we've used the data. The radius of a circle is 13 centimeters and length of one of its chords is 10 centimeters. Now what do? How do we use these two data to get the distance of the chord from the center? So that means to say we need to get this distance from the center. Now if we can go back to the properties, some important properties of circles that we've done before, it clearly says that the perpendicular from the center of a circle to the chord bisects the chord. So if this chord is 10 centimeters, then this perpendicular has bisected this chord into 5 centimeters and 5 centimeters. And one more important point is this is a perpendicular to the chord. So this is going to be 90 degrees here. So now what we can do is we can take this as a right angle triangle, the green one. This is going to be 90 degrees and we know that this length is 5 centimeters because half of 10 centimeters is 5 centimeters. And why half? Because it is being bisected by this perpendicular. So now considering this right angle triangle separately here, we have 5 centimeters and 13 centimeters. We just need to find the length of the other side, which is very easy based on the Pythagoras theorem. So say for example, let us name this as O, A and say L. So it will be OA square equals AL square plus OL square. We know that OA square is equal to 13 square, AL square is equal to 5 square plus OL square is what we need to find. So 13 square minus 5 square is equal to OL square, or OL square equals 13 square minus 5 square. So OL square equals 13 square is nothing but 169, 5 square is 25. So 169 minus 25 is 144. So OL square is 144, OL is equal to root of 144. So root of 144 or square root of 144 is nothing but 12. So OL equals 12 centimeters. So the distance of the chord from the center is equal to 12 centimeters. And we found this by using one of the properties of the circles that we already discussed. So I think this is proof how important are those properties to us. Let us quickly solve another problem. Now here the question goes like this. Find the length of a chord which is at a distance of 5 centimeters from the center of a circle of radius 13 centimeters. So this is not very different from the previous sum that we solved. This is just the other way around. In this problem, we have the distance of the chord from the center and the radius of the circle. We need to find the length of the chord. So let us draw the diagram now. So here we've got a circle. This is the center now. Now we have the distance of the chord from the center, which is nothing but 5 centimeters. So this length is 5 centimeters. And the radius of the circle is 13 centimeters. So we need to find this length. We first have to find this length and double it to find the length of the entire chord. The entire chord is from this point to this point, but we cannot find this straight away because we first have to consider this right angle which contains exactly half the chord. Again, this follows from the property that a chord which has got a line perpendicular from the center of the circle bisects the chord. So that is the concept we are using here again. So now considering this right angle, say let us name them OAC. Let this be B. So now considering the right angle OAC, we have this as 13 and we have this as 5. We need to find this length again. So now using the hypotenuse rule, we have OA square equals AC square plus OC square. OA square equals 13 square. AC square is what we have to find. OC square is 5 square. So AC square is nothing but 13 square minus 5 square. So AC square is 169. 13 square is 169. 5 square is 25. So AC square equals 144. AC equals square root of 144, or AC equals 12 centimeters. So therefore we found AC to be equal to 12 centimeters. But then we found only the length of half the chord. So what is the total length of the chord? If half is 12, then the total would be the double of the half. So therefore it will be 12 into 2, which is 24 centimeters. So therefore the length of the chord AB equals 24 centimeters.